Hi everyone, and welcome back to the SaaS developer community, where we share interesting technical ideas and learn from each other. And today I have with me what I would consider a fairly hot topic about an open source project that was very recently released live at Strangeloop. We have Felix, who is a principal engineer at LinkedIn, and the lead, I think since day one, essentially, of Venice project. I think for the last, I don't know how many years, maybe 5 or 6, every time, like, Felix, I heard so much about Venice. It's so exciting. When are you guys going to open source it? And they finally had, so I had to have him on the show to talk about it.
Yeah, glad to be here. Thanks for the invitation. And sorry that it took so long.
It's just happy that it finally happened. It didn't take long for anyone else. For everyone else, just it showed up and they can be happy about it.
I guess so.
Yeah, so let's start with the basics. What is Venice?
Yeah, so Venice is what we call a derived data store or derived data platform. Essentially, it specializes in ingesting data that's been processed, right? So you can think of machine-generated data. A lot of our use cases are in the AI space. So it could be the output of ML training jobs or even ML batch inference jobs. So a bunch of like scores or embeddings. These are very common data types that we have in Venice. We also have like some non-AI use cases, like essentially some materialized views processed from other upstream data sources that then need to be served at low latency to online applications. So that's kind of the niche. To be honest, we're still kind of fishing around for what the right label is for the project. It sometimes feels like there isn't a lot of comparators to draw from. Like it's not like the open source version of X, Google paper or something, right? So I'm sure other companies have similar systems internally, but in open source, I haven't found a lot of similar systems to compare with so far.
So yeah, listeners, if you have ideas of what to call a store that is derived data store but with a lot of its own interesting capabilities, then do share suggestions below and or go to the GitHub project. And I guess you can open issues or suggestions and ask people to rename things and enjoy the discussion about naming things on a GitHub project.
Yeah, exactly.
I don't know why I'm doing this to people, but yes. So I want you to kind of give an overview of the properties of the system. I know you mentioned that it's a distributed system.
Mm-hmm.
What's the data abstractions around it? Like what's the general data model of data that goes into Venice?
Yeah, that's a good question. So I think the most important concept in terms of the data model is that in Venice, the data sets are versioned, right? So when I say data set, you could alternatively call it a store or a table. But essentially, a data set is versioned, and there is first-class support for swapping the whole data set to a new version, what we call rolling forward. Alternatively, if the user pushed a wrong version that maybe somehow degrades business metrics or whatever, they can quickly roll back to the previous dataset version as well. So that's kind of a very important primitive of the system that the user can essentially swap the entire dataset. And then in addition to that, if the user is doing like nearline updates, like streaming writes, for example, into the system, then that also gets orchestrated in a way that we call hybrid. So that means you can have essentially a hybrid of batch pushes and streaming writes all get combined together. So that's another kind of important concept of the system, that the table could be, either batch only or stream only, or it could be hybrid.
Yeah. And by the way, this talk is going to touch on a lot of things, and a lot of them have a lot more depth in Strangeloop presentations that Felix gave. So one of the things that really struck me the most when I watched the presentation is that I don't think there's any system in the world that supports as many different form of ingests as Venice, and they all look useful. So when Felix presented it, he's like, oh yeah, I totally can see why I need this, and I also need that. So I think there is like 4 or 5, depending on how you count, distinct ways to get different types of data into Venice, and this part looked very unique and very interesting. So yeah, link below to the YouTube, and there'll also be something clickable. I'll get YouTube to do some magic there.
Yeah, there is also a blog post, which is kind of the companion to this video. It contains mostly the same content. So if people prefer reading than video, they could take a look at that as well.
So
they
can
kind of
you say
mirror
what
each
blog
other.
is called? Because when I went to your GitHub project on the README, there is like 5, 10, I don't know, like I think 10 blog posts and 5 talks. And it was not always easy, like if I want to answer a specific question, which one of the blogs would have it? So is it like the last blog on the list that people should look at? Or
That's right. Yeah, the last one called Open Sourcing Venice. There is a talk version and a blog version of that
makes
content.
sense. Yes. So let's go back 5 years or 6 years ago. What made you or your team kind of like, hey, we need a new database?
Yeah. So when I joined LinkedIn, I was originally in the Voldemort team, and at some point, Voldemort powered basically everything at LinkedIn that wasn't in Oracle. Right. At first there was just Oracle, then there was Oracle and Voldemort, and everything that needed scale was on Voldemort. And then after that, people started chipping away at the Voldemort use cases to go into more specialized solutions. Like search got its own special thing, graph got its own special thing, OLAP went into Pinot, but all of those originally were in Voldemort. When I got there, one of the major category of use cases still remaining in Voldemort was what we call read-only, which is the stuff that gets batch pushed with a swapping behavior, kind of like what I described earlier. And we noticed that this was giving our internal users a ton of productivity, right? They could play around with a Hadoop workflow that generates a bunch of data, and then it was sort of like a single click, basically, almost, to materialize that data in a queryable online store for their apps to query. And at the time, we were somewhat early in the stream processing game, right? We had just open sourced Stanza, and we thought stream processing was up and coming, but it was sort of shackled in a sense. Like the output of those jobs could not easily flow back into online serving. So essentially, the original motivation for Venice was, let's do for streaming what Voldemort read-only did for batch, right? Unleash the data so that online apps can query it. So in a sense, it was kind of a lateral shift of the scope of Voldemort. It threw away some parts of the Voldemort scope that were now getting served by other systems, double down on the Voldemort read-only, like batch push kind of stuff to support that, but then also expand into what would it be like to have first-class support for ingesting streams in a highly productive way. And of course, we did consider, should we keep expanding Voldemort instead? Should we adopt something like HBase or something else. And there was an in-depth analysis basically at the time, and we ended up deciding on building a new system. However, we should qualify that. Like it's not like we're building everything from scratch, right? Like we are in fact standing on the shoulders of giants. Like we leverage Kafka, Helix, RocksDB, a bunch of other technologies. So it is a new database, but it's also leveraging lots of very solid open source components that already exist.
So Kafka and Helix were mentioned in your Strangeloop talk and what they do in the system. RocksDB is what you use for storage, essentially?
Yeah.
Makes sense. Cool. So in your talk, you mentioned gazillion use cases, and just like I'm going to just rattle off this long list. You had standardization, you had newsfeed recommendations, people you may know, A/B testing, ads, search. I'm probably missing a few because it's super diverse set of, from the utilitarian to the extremely advanced and sophisticated. Do you have favorites?
Well, that's a tough question. I mean, I think like I got a soft spot for the more advanced kind of use cases, like that really push the limits and are the partners that we end up needing to develop new functionalities for. Those tend to be the most challenging and interesting in a sense. Although they are also fairly niche, like the vast majority of Venice users are doing much simpler things in a very self-service kind of way that they just get their work done, and that's also very valuable, right? So this is not a reflection of necessarily the business value. It's just a reflection of how challenging to build and support these use cases are. But like essentially the most sophisticated ones that are mentioned in the talk, I guess, are people you may know, the search infra, the feed. Those are sort of the heavy hitters, I guess, in terms of sophistication and complexity. So
yeah.
very
And I have to say,
interesting.
at least personally, one of the most interesting parts of your talk was really when you talked about Da Vinci and the kind of, I don't know if I want to call it materials view, but it's kind of like an unique type of cache. You call it eager cache, which for me was a new term. I was not familiar with the space at all. And at first it's like, yeah, this is not a cache, this is a copy. But then you talked about really how flexible you are around partitioning and so on. So for me, this was maybe the newest part of the system and sounded like ads and search are some use cases, but I bet there's just so much to explore there.
Yeah. Da Vinci is pretty interesting. Essentially, Da Vinci is a client for accessing the Venice data, which has the same APIs as what we call the classical Venice client. So you can get data, batch get a bunch of keys, or even compute some things on a set of keys and get the result of those computations back. So same APIs, but under the hood, instead of doing a remote query to the backend, it consults local data structures that exist within the host that the application is in. So it's a very different cost performance trade-off, right? Like, of course, you're going to have a higher cost from needing like local RAM or local SSD, depending how you configure it. But you'll get, blazing fast latency and be able to support very high throughput. I think the interesting thing is the similarity of API, right? I mean, it's basically the same API. So the goal was that applications shouldn't need to make the decision up front about what is the right cost performance trade-off for them. They can they can start with, let's say, classical Venice, which is the easiest because you don't need any special resources provisioned in your app. But then if your use case grows to a certain scale where you feel like you need a higher throughput or lower latency, then it's basically a config switch. And moreover, you can even have mixed workloads where some applications will be doing remote queries and some applications will be doing the local queries against exactly the same data, basically. This is something that we sometimes call L1 and L2 in AI recommendation systems. They will have like an L1 layer that queries a very large number of entities and does some lightweight scoring on that and returns the top K most relevant things out of that L1 layer. And then at the L2 layer, it's like a funnel. There are fewer things happening there, but for each of them, they will query more data and then run a more expensive scoring algorithm or ML model. And so that's a pretty common pattern we see. And we think it's nice if the engineers can have sort of a unified API, regardless of whether they're in one context or the other.
Yeah, absolutely. I think it's brilliant. And you mentioned A/B testing as one of your examples. I think Launch Darkly has kind of similar idea in the client, where the client, as you said, eagerly caches everything it can, like the set of the combinations that every client has to worry about is fairly small. Like if you go to one server, you only have a subset of the experiments, but it's again not going all the way to a remote server to check what to show every user is a big deal. So that it is a pretty awesome pattern, and I kind of hope that more databases will start doing it. So so far we talked kind of at a bit of a high level, but when I listened to your talk from Strangeloop, I had some detailed questions that I was hoping you can enlighten me. So I'm going to refer to specific parts of the talk so people can follow along. I'll try to put correct links in the notes so it will not be too messy for people who did not yet watch your talk. So we talked about the million ways that Venice allows loading data. And one of the interesting ones to me was the partial writes, which is very normal if all you do is relational databases. Of course, you can update just some columns in a dataset. But if you look at things that are less structured, then it's obviously rare. And if you look at things that have this kind of streaming loading and batch loading, I think it's pretty unique. So yeah, if you can briefly describe it, and then I need to understand, because it just seems like you rely a lot on people not making mistakes, I would say. And so I'd love to hear just how it went in practice and how people use it.
Yeah, so I think like as part of the NoSQL movement, we as an industry we kind of forgot some of the good stuff of SQL, right? So which is maybe what you alluded to in the beginning of your question. So if you look at the like very bare bones key value store, the values in the store are probably going to be more than just one piece of data, right? It's going to be more like a row that contains many things. And so a common use case that we see with these kind of NoSQL system is that applications really want to mutate just one of the columns of that row. And because the key value store is not giving them rich enough operations, they're going to read some record out of the key value store, then modify it inside their application and write the whole thing back. And this is a bit unfortunate in a sense, right? Like, because they wanted to modify like 10% of the thing, and instead of sending the 10% into the database, they're retrieving 100% of it, doing work on the application side, and writing back 100% of it. Like it's not very efficient. But besides efficiency, it's also error prone, right? Because if you have multiple applications doing that concurrently and they have a chance of hitting the same rows, then it's possible that they clubber each other's writes. So then you start having sort of like layers of Band-Aid on top of that, which are like, well, I'll give first class support for a CAS operation, compare and swap, right? So then the applications are now going to do even more complicated stuff. Like instead of writing the whole row back at the end of their read, modify, write cycle, they'll do like a version write, which says, please accept this write if what's currently in the DB is what I expect. Otherwise, please fail it, and then I'll retry the whole sequence. And with this kind of support, it is possible for applications to achieve correctness, but then it becomes even less efficient, right? Because if you have contention, multiple applications are going to need to retry, and we've seen cases like this that had difficulty scaling at LinkedIn because although the DB was providing all these primitives, in the end, these are just not the most useful primitives compared to a plain old SQL update statement. So in Venice, we wanted to try to do better than that. So we built first class support for updates in a way that the application can send just the 10% that wants to change and let the DB figure out how to merge it in, even if there are concurrent writes happening. So this allows the application to essentially always do one operation, not like have a chance of retrying and so on, and no need to read before each write either. So it's even just in steady state, when there's no contention, it's more efficient. But then when there is contention of many concurrent writers, then it becomes even more efficient because it's a flat cost, like just one write operation per upstream operation, essentially. So we built support for that, and I think it's even more important in the context of derived data serving and loading, because when you need to support the kind of operations I touched on earlier, where you're batch loading a whole new version of the data set and swapping it in place, it may not be good enough to swap that version in place and then start applying streaming writes on top of that again, right? Because you may have like a gap of missing data if you do that. So what Venice does in those cases that we call hybrid, like I mentioned earlier, is that Venice will replay the recent streaming writes on top of the new version data set. And those streaming writes can include partial updates, right? So then the partial updates can get overlaid on top of essentially a new snapshot of the data. So this allows the user to essentially compose these various data sources in ways that are very flexible and also kind of unlikely to be misused, I would say, right? Because a lot is getting handled out of the box by the system instead of letting applications absorb a lot of the complexity.
Absolutely. This is, it seems amazing, but it also seems like something that applications can still mess up quite badly. Like, is there, I think I'm the one should be updating this column, but someone else has their own job that should be doing it. Or even one of the issues we've seen when we try to do exactly once with Kafka is that clients sometimes happens, you start a new one, it starts updating things with new information, and then the old one comes back to life, and it has its own in-memory state of stuff that it wanted to write, and it starts overwriting with old information, which is just not just surprising, but also can be extremely hard to debug. Where does this thing come from, and what's the... We call it zombies, essentially. They come back from the dead to hunt you.
Yeah,
So
definitely.
I'm wondering if you ran into it, if that's like a big problem that you feel you need to solve, or less of an issue in Venice.
Yeah, definitely. It is I think it is a real legitimate issue, and we are working on solving that as well. So one thing I didn't mention yet is we support conflict resolution in cases of concurrent writes, and so what's going to happen by default, like if you don't do anything special, is each write that you emit to Venice is going to be stamped with the local clock of the machine that emitted the write, which could be like a stream processing instance, for example, right? So that's the default behavior. But if the application that is writing to Venice has a more precise notion of time that is specific to their domain, like for example, maybe the stream processing application has an input which is change capture of a source of truth database, right? Then that change capture input stream could contain a timestamp which belongs to the upstream database, essentially, right? So then, in that case, the user can pass along this logical timestamp into the write to Venice, and
you resolve it correctly.
Yeah. So essentially, that's exactly for the scenario you described, which is that stream processing jobs, they sometimes fall behind. Because of maintenance that was planned or unplanned, and when they come back up, the beautiful thing about stream processing is that it can catch up, right? Because its input, well, assuming you're using a persistent buffer like Kafka, for example, then the input of the stream processor is still there, so they can catch up to whatever they missed. But what they're catching up on might be old, maybe like it's an hour old, and they'll run through that very fast, right, to catch up to the most up-to-date events. But if it happens to be the case that the Venice table is getting updated by multiple writers, and one of them it has fallen behind by an hour and it's catching up on that lag, it is possible that some of those writes would need to be discarded, actually, because they've already been superseded by most recent writes from other instances that happen to touch the same keys. So yeah, that I think that's a real issue, and we are trying to provide support for that as well.
Yeah, and I like the idea of using upstream information, because that's a very, very common pattern, and the whole outbox pattern of putting CDC in front of things like Kafka and so on, and really using this information and the fact that the database is serializable, linearizable, has all those nice properties in order to push those nice properties further down the stream is something that has worked really well in use cases large and small, I would say.
Right.
Another detailed question about a part of your talk. You talked extremely briefly about batch gets, and the example you used, you said that batch gets is basically get a batch of keys, which I get. So you give a set of keys and you get the data back. And then your example was, I want the top 10 recommended news for user, which also sounds great. But how do you map top 10 into a bunch of keys? There must be a lot of interesting processing and like a good data model that, and you have to push the data correctly in order for Venice to do it in this kind of operation. So I was curious, how do you lay out top 10 recommendations as a batch read?
Yeah, so I mentioned that in the Strangeloop talk in the context of the feed use case, right? Which is a heavy user of batch get. And the feed is doing this sort of scoring and top K use case. I may not have been like completely clear in the talk about what the boundary of each system is, but so let me try to clarify that. So in that use case, that particular use case, Venice is not performing a top K, right? It is the application that's performing the top K. So Venice is focusing in that case on just returning the full values for the set of keys that were queried. And the application, which is the feed, or more specifically, we call it the feed mixer, because it's looking at a bunch of potential things that it could present to the user and kind of mixing them all up together, and ranking their relevancy. So in that case, the feed cares about getting those full values back, and it will feed those values into its ML model for scoring the relevancy.
Got it.
So yeah, at this time, Venice doesn't support top K natively. This, although it's very common that our applications end up doing that, but they do that after the scoring happened. Which most commonly is happening inside the application. It might make sense at some point to provide built-in support for that in Venice, but for now, there is no sort of top K within Venice.
Yeah. So speaking of native support of things in Venice, one of the things that is definitely unique, if you just think of, if you attempt to think of Venice as a key value store, which you really shouldn't, one of the things that will look like magical superpower is how much push into Venice you do. I think you called it querying, but I'm not 100% sure. It's you mentioned that you can push Venice to do projections or even apply mathematical functions inside Venice to make machine learning more efficient. One thing you did not mention was filtering, and filtering pushdown is so common. I was wondering if you actually don't do it or if you just forgot to mention it in the talk.
Yeah, so filtering is something we explored with some of our internal partners. So I think it is definitely relevant to some of our use cases. So far, it hasn't been prioritized, but I think it makes sense to have it within the scope of Venice. So yeah, it could happen that we add support for filtering. I think it makes a lot of sense for our use cases from what I've seen. But so
it's
far
surprising that you haven't had more pressure to do it, because Kafka doesn't do filtering either. Like if you have subscribed to a partition, you get every single thing that is written to that partition. And people were definitely asking for that a lot. I don't need everything in that partition. I didn't choose the partitioning strategy. I'm just the consumer here, but I don't want to read all of that. So it's kind of, but I guess it's really, now that you're open source, you'll probably get exposed to bigger variety of use cases and people trying to do a lot more things, is my guess. So for people who got really excited about Venice capabilities and just spent a bunch of time thinking, oh, I can do this with that, I can do that with this. For me, one of the questions is, what does it take for me to actually run Venice? Like I'm a small startup, I don't have big data. What do I need to run? How many services? How many machines? What will be the cost of operating it?
Yeah, so that's a good question, and I think it's still pretty early days. Like when we actually released in open source at Strangeloop, the project was in a state where it recently started building outside the LinkedIn VPN, right? So that's basically the bare minimum, right? Like it builds. Now since then we've added a few more things. We've added like you know Maven artifacts. We've added Docker images. We're starting to add documentation. We have like a trove of internal documentation, but we sort of need to curate it a little bit because it's sort of sprinkled with like irrelevant information that are kind of internal. So we have to kind of clean up the doc a little bit before putting it out. So all of that is still in progress, basically. Another thing that we're kind of missing is the CI. Our CI is still internal, but we're in the process of moving it to GitHub Actions.
Good
So
choice, by the way.
it is, yeah, it looks promising. So it's still very early days, right? Like I think at this stage you gotta be like an early adopter type. Like for example, when I first used Kafka personally was before the first Apache incubation release. Like it was like the
You were showing off your hipster creds. I used Kafka
yeah, I
before it
guess
was
like
even an Apache project.
I mean, it was in Apache incubation, but there had not been a real release yet. Like it was like 0.6 something. I don't know. And and I think it can be very interesting to be an early adopter, but it is more effort, right? And we do hope to make it easier over time. Like we're about to publish an update of our Docker images that support the multi-region setup, for example. Currently, the Docker images support only the single region setup, which is maybe the single region is maybe the way you would want to get started anyway. But yeah, so you ask like, what does it take to run Venice, right? So
Yeah.
in terms of like moving parts or dependencies, currently the bare minimum dependencies you need today to run Venice is Kafka and Zookeeper. Right, you got to have those. Those are it's not going to work without Kafka and Zookeeper. Everything else is sort of in the most minimal form is going to be embedded inside Venice. So, for example, there is Helix, but we embed Helix inside
Oh,
Venice,
I
right?
was just about to
Um,
ask that. Do I actually need to run Helix? But you solved the problem so for me. Apparently, I
so
don't get a choice, and you'll be running Helix.
well, you do get a choice. Like internally at LinkedIn, we have a dedicated Helix team, so we run Helix as a separate service. So Venice can work both ways, right? But for somebody who's just getting started, they probably like will not want like extra moving parts. So Kafka and Zookeeper are basically the bare minimum as of today. Uh, and then it's not mandatory to have Hadoop. You can run without Hadoop if you have stream only use cases, but I think a lot of use cases, from what I've seen, do care about pushing data from Hadoop. So, but anyway, Hadoop is pretty common nowadays. So it's probably not a stretch to imagine that people will have that in one form or another. So that's kind of
Curious what
how
you
it looks.
mean about Hadoop being very common today, because I think I went years without seeing Hadoop. Everyone uses S3 for storage. They use a lot of Spark.
Oh,
There are
sure.
various kinds of data lakes. Do you mean like the stuff that Hadoop evolved into, or actually like HDFS and MapReduce kind of Hadoop?
Uh, yeah, I mean, you're right. It has sort of evolved into like cloud native alternatives and stuff like that. It so I never tried yet like running, let's say, a Venice push job that takes data out of S3, for example. I think there is like an S3 client for HDFS, so in theory it should work, but there may be some rough edges there because we never tried it. So yeah, I think like it will help make the system more versatile if people in the community try running it in different cloud environments and stuff like that.
I mean, like, think about the opportunities to be the first person in the world to run it with Spark or S3 or all those things, Venice on your data lake. It's just like it's exciting for people to get involved in a project that early. I mean, obviously the right kind of people, but there is a lot of excitement going on where everything is like you're the first person in the world to do a lot of things. You don't get it in more mature projects.
Yeah.
So this may be sensitive, and I may need to cut it out of the video. Do you have any thoughts and plans about Venice as a managed service? Either like by the Azure team who may have gotten excited about it, or just someone in the community who is thinking that, hey, this could be a nice gig?
Yeah, so internally at LinkedIn, we run it as a managed service, and I think this is how the most like value can be extracted out of it, right? Like having, I mean, at small scale, it's fine if the user and the operator is actually the same person, but I think you get like higher leverage if it's offered as a managed service. So I think it definitely makes sense. I think it would be great if Venice becomes mature enough and generally useful enough that that some businesses feel it makes sense commercially to offer it as a managed service. I kind of hope that if it happens, that there will be more than one vendor doing it, because I think some projects that are single vendor, it sometimes ends up being a little bit negative for the community. So for example, like if let's say both Azure and AWS, or both Azure and a startup or whatever, were offering Venice as a service, I think that would be a great outcome, actually. And hopefully the balance of these various actors could help keep the project thriving. So yeah, we'll see. I mean, but again, for now, it's like very early days. So there is no such plan that, at least that I'm aware of. Maybe people are cooking up their own plans, but there is no such plans that I'm aware of right now.
Since you are running it as a managed service internally, I was wondering if you have advised a lot of the people in the community. Obviously, they're not running Venice as a managed service, but they are working on deep technology as a managed service. A lot of stream processing as a service, database as a service. Do you have any kind of general advice on the managed service aspects that you had to do for Venice?
Yeah, definitely. So that's a pretty common topic of discussion within the team at LinkedIn that operates and develops Venice. Well, these are technically two teams, like the dev team and SRE teams, but we are tightly embedded. So we often think of it as one big team. And for us, like our internal compass for determining the quality of a given functionality is it GA, right? And what we mean by GA is it can be onboarded self-service by the user, in this case, like an internal user, like at LinkedIn, without us needing to know that they onboarded, right? So that means, they have this sort of self-service provisioning console that they use, which is an internal thing at LinkedIn. It's not part of the open source, at least not at this time. And they click a few things, and we also have other use cases that even dynamically provision Venice datasets without even anybody clicking anything. It's just like a workflow that dynamically does it. So we have all of these new data sets getting created like every week, sometimes multiple times a day, and deleted also continuously. And we want this stuff to be rock solid enough that the user doesn't need any special support, either because it was just so damn obvious, or else that they could unblock themselves with the documentation, right? So that's kind of the bar that we're striving for, and not every functionality within Venice is at that stage yet. We have some things that are much more experimental, but we have like several core functionalities that are at that stage of maturity that people can just onboard on their own, and like as operators, we don't even need to know that it happened.
And that's kind of the dream. Stuff just happens. You don't have to do any work. You did your work already.
Exactly.
Felix, thank you so much for joining us and sharing interesting use cases, ideas about a really cool new project with a lot of potential in the world, and advice on how to build good managed services. So
cool. Thank you. I hope we can do it again at some point when the project is more mature.
Absolutely. Yeah, and then we will talk about the community use cases. This will be exciting in its own right.
Cool. All right. Well, thanks for having me.